Yes, class, am I audible to all of you? Alan, Farhat, Hiba, Saif, Hanifa.
Yes, sir.
All right. So yes, yesterday we had started with kinematics and we had completed motion in 1D. So motion in 2D is left. Now motion in 2D, you mainly have vectors first. So vectors you have already discussed. Vectors are completed. We'll now move directly to angular projection because dot product, cross product, all these basics of vectors, parallelogram law, physical quantities, these you already had a class. Now from angular projection, you should remember the basic formulas for it. That is sufficient. Derivations are not very important to learn because derivations in any ways are not coming, but they are not even going to be helpful for your numerical solving. So you should just solve everything along x-axis, along y-axis. So equation of trajectory along x-axis, how will you calculate? X-axis, there isn't any acceleration, but there is acceleration along the y-axis, that is acceleration due to gravity. So acceleration due to gravity is going to be there, but when you're talking about x-axis, ax is going to be 0. So your equation will also become ut plus half at square. Everything will be in terms of x. Acceleration of x-axis, initial velocity of x-axis, like this you will take. And see, when you'll resolve it, along y-axis you are getting uy sine theta, along x-axis you are getting ux cos theta, which is u cos theta. So here also you will use u cos theta. So time period will become x is equal to u cos theta t. So time becomes x divided by u cos theta. This is along x-axis. Same thing along y-axis, what will happen? U sine theta will be the velocity that you will be considering, and acceleration due to gravity will be the acceleration that you have to consider, because acceleration is there along y-axis. It wasn't there when you were discussing it along the x-axis. Same thing, y equation you will put it. So final equation of trajectory, you have it as x tan theta minus g x square divided by 2u square cos square theta. So tan theta, theta is basically the angle of projection. Theta is angle of projection. So theta is the angle of projection. So y is equal to x tan theta minus g. G is acceleration due to gravity. 2u square, u is the initial velocity. Initial velocity, or the term can be used as projectile velocity. Again, cos square theta. Then time of flight basically means the entire time. For example, I have thrown this. So entire time that it will take to cross from here to reach here. This is from here the projectile has moved till here it is coming. So when the projectile is coming here, this means the entire times that has elapsed. This is known as time of flight. Fine. So time of flight directly formula you can remember 2u sine theta by g. That's it. But here, see, remember class, this is entire. But if I say from here, this is moving, this has stopped till here. Fine, this has stopped till here. So this has covered just the half of time. So this is time of ascent, which is half of 2u sine theta by g. So only u sine theta by g will be used. Fine, class. And after here, when it will come back to the ground, this is time of descent. That is again u sine theta by g. When we were discussing motion under gravity also, this I forgot to tell you. If you are throwing a ball, it is going up, then with the same pathway it is coming down also. So this is time of ascent, this is time of descent. So if frictional forces do not come, any dissipative forces, heat, energy, and all these are not present in your system, then time of ascent becomes equal to time of descent. Fine, time of ascent and time of descent both are equal. But if your frictional forces these are present, so time of descent will be greater because it will take time to come back to the ground. Fine. This is time period. Range also, see, for range basically means if this much distance is covered. No, let's say from here a projectile has been thrown and the projectile lands here. So the x-axis distance, the vertical distance that has taken, the horizontal distance that has occurred, can be vertical also depending upon the projectile from its initial and final position. Initial and final position, right? Initial and final position. So this separation is known as range. So u square sine 2 theta by g you should remember, as well as you have to remember this formula u square 2 sine theta cos theta by g, because the formula that we have, trigonometric identity we have, sine 2 theta is equal to 2 sine theta cos theta. So using this, you get the values of range. Now you have the values of maximum time period, you have maximum range depending upon angle. So here in case of maximum range, our sine 2 theta has to be somehow, it has to be 1. So when sine 2 theta becomes 1, range becomes u square by g, and that is the maximum value that is possible. So for that, theta is 45 degree. So you have to remember that for 45 degree, you get the maximum range. Then for complementary angles, you should remember if for range of motion, if you are taking complementary angles, whichever complementary angle means two angles which have the sum as 90 degree. So whatever is the angle that are made, both of them will let the body reach the same position from the origin. That is, range of motion will remain same. So whether it's a complementary angle, whether it's like 60 plus 30 or 45 plus 45 or 10 and 80, anything which has the sum x plus y has to be 90 degrees. This has to be 90 degrees. So the complementary angle sum should be 90 degrees, and that is equal in case of range. When you're calculating the range of motion, the sum is equal. Now see, you have height and height in, you have a maximum height and you have the values of maximum height. See, this is entire projectile motion. So you are having these many heights. Out of all these heights, this one is the maximum. This one is the maximum height. So maximum height is the separation from the ground to which the projectile has risen, maximum. See, so maximum height is one of the values. Out of all the values of height, maximum height's value is this. Now see, a question can be confusing in the sense when two maximum heights of different projectiles are mentioned. So first maximum height means maximum height out of all of these height, 1, 2, 3, 4, 5. Out of all of these heights, which one is the maximum height? Other one becomes the height that is maximum, the other height that is maximum if two projectiles are compared. One height of one projectile is given, another height of another projectile is given. So maximum height usually is the middle one. Fine. So height is u square sine square theta divided by 2g. U is again the initial projectile velocity. So theta is the angle of projection. G is acceleration due to gravity. So sine theta's value is 1. So sine square theta is 1. Theta is 90 degree. So you should remember at 45 degree you were getting the maximum range. At 90 degrees you were getting maximum value of height. Fine. So these are separation between these. Just a second. See, height. So yes, 90 degrees for maximum value of height, because even if the question comes, so you should not waste your time in solving everything. So you should just remember the value. So 45 degrees it was for range of motion, and 90 degrees it is for the height. So u square by 2g, you'll get the maximum value. Then you have velocity. See, velocity, you just have to solve the way you solve individual velocities along x-axis and y-axis. That will be sufficient. Velocity along x-axis, get velocity along y-axis, fine, and take out their resultant the way you use using parallelogram law, using your Cartesian form, whichever method you prefer. I cap, j cap, k cap, in terms of these also you can mention. Otherwise, using your polar vectors, that is in terms of theta also you can mention, that is along x-axis, fine. So yes, same thing. Vx is equal to u cos theta and Vy is equal to u sin theta minus gt. Here also there would have been an acceleration, but we know across x-axis ax is 0, acceleration is 0. So total velocity is under root Vx square plus Vy square, and tan beta is velocity across y-axis divided by velocity across x-axis. So Vx by Vy, that is the tan beta's value. So yes, there are certain conditions. Again, we should remember that there shouldn't be any change in the velocity along x-axis. Along x-axis, the velocity should remain same. And acceleration along x-axis is 0, ax is 0, and force along x-axis is 0. If along x-axis you are able to see that these three conditions are satisfied, no, there is the velocity across x-axis is not changing, there isn't any acceleration is there, so automatically force is also not there, that will be satisfying half the criteria for it. Other half criteria for projectile motion will be that acceleration or due to gravity should act along the y-axis, and velocity will be 0 along y-axis at the highest point, fine. Velocity y is 0 at the highest. So these are all the basics of the formula. This much is sufficient for question solving. Yes, if suppose angle is not given, this was at certain angle, no? Thrown at certain angle. Let's say certain angle is not given. Horizontal projectile means when the angle with the x-axis is 0, means it is parallel. So from the origin, if you're throwing it at a particular height, if you're throwing a ball or an object, a projectile motion is being followed, but there isn't any angle that is fine. If angle is made, you will follow all of the topics and all of the formulas that we have just discussed. But for horizontal projection, just see whether it's horizontal projection mentioned. If it is written parallel to the x-axis, making an angle of 0 degree, any of these is written, just directly go and use the formulas of horizontal projection. Horizontal projection is very, very much easier than your angular projection. Angular projection still has a lot of concept. Horizontal projection, the formulas are very easy. Half g x square by u square, and time period is x by u. There you had u cos theta. Here that also gets eliminated. X tan theta is also eliminated. So this much simple formula. Time period, this is under root 2h by g. So for height you can use half g capital T square. Range of motion, just multiply initial velocity with time, that will give you range of motion. So u under root 2h by g. 2h by g was the formula for time period. So u under root 2h by g will become the formula for it. And velocity at any instant, same thing. Here you won't be having minus sine theta component, no component will be there, and maximum initial velocity across y is also 0. So the way you solve, no, normal velocity across x-axis, get a velocity across y-axis, write it, and then finally the resultant using your Cartesian form, using your polar form, whichever form you prefer. But here using polar form is not very beneficial. You can directly use your parallelogram law. Most probably they'll be making an angle of 0 degree also, that is also clear. But best method to solve it is using I cap and j cap, and tan beta will also remain the same. Nothing else is very important from this. Rest of the topics we'll cover through questions. Let us see all these questions through questions. Okay, so again, same thing. I'll be noting down the question. Then first note it down, send me your answers, then I'll discuss it. Yes, Alan, your answer is right. 2 more minutes, then I'll discuss the solution. Others also send me your answers. Option, just send me the option. So Saif, Farhat, and Alan, they have answered correctly. Rest of you, some errors you have committed. Let me discuss it now. See, if I draw the diagram of it, this would somehow look like this. This is one building, this is another building. So 200 meter is their height. One projectile from this side, one projectile from this side. With this is 25 meter per second. This is 200 meters, right? And the separation between the buildings, this is 100 meters, right? Now, net relative velocity, if you find out firstly, because both are moving. So if one direction positive, yesterday only I have told you one has to be negative. So other than one will become minus 25. One plus 25, other as minus 25. So that becomes 50 meters per second. Time is separation, distance by velocity. So 100 by 50 is 2 seconds. Now you can use your simple kinematics equation. X is equal to, if you use x is equal to ut plus half at square. Now see, acceleration will be minus g, because this is acceleration, this will become going to be minus g. Now see, here x will then become minus half gt square. right? Because initially they are at rest, u is 0. Initially it is at rest. So now if you put it, x is equal to minus half into 10 into 2 square, that is going to be minus 20 meters. So from where will they collide? From below 20, just subtract 20 from here. So that becomes, if this is 20, this leftover part will become 180 meters. So you have both 2 seconds and 180 meters. In which option? 180 meters and 2 seconds, A option. Note it down, those who haven't. I'm writing the other question till the time. Yes, so only till now, Farhat has answered correctly. See, I'll explain you. When an object is shot from the bottom of a long, smooth, inclined plane, kept at an angle 60 degree with horizontal, it can travel a distance x1 along the plane. But when the inclination is decreased to 30 degree and the same object is shot with the same velocity, it can travel x2 distance. So the ratio of x1 and x2, you have to find it out. See, uh, x's formula, which we had seen, was what? U square by 2g sine theta. This was what we had concluded. So just put in the values in this formula only. If you want to see the derivation of this, I'll tell you. But if you just directly put it, I think the answer will be sufficient. See, x1 will become u square 2g sine, first one was 60 degree. X2 will become u square by 2g sine 30 degree. So x1 by x2, u square by 2g sine 60 degrees into 2g sine 30 degrees by u square. So you have half into root 3 by 2. That becomes 1 is to root 3. Safe, which option? 20 minus 24. No, the options I have written, no options. 0, 5, minus 4, and minus 8. See, for velocity across the x-axis, first differentiate the x-axis equation. See, x I am writing here, 5t minus 2t cube. If you differentiate dx over dt, that will be 5 minus, this is 3 minus 60. Or this is square. This is square actually. Wait. That's why you must be getting a different answer. This is square. By mistake, I have written it as cube.
Okay.
So this is 60. No, this will become 40 then. So acceleration will become minus 4 only. Yes, no, right. I think because of the square, no, by mistake I did in 3. That's why your answer was coming different. Yes, so acceleration is minus 4 meter per second square. Even if you differentiate 10t, velocity will become 10 and acceleration will become 0. So you have final answer as 4, minus 4 only. Yes, so Hanifa, Alan, and Saifullah, they have answered it correctly. Rest of you just see. See, for the position T is equal to 0. T is equal to 0. What was given? 6 and 7, no? 2 and 3. Okay. So 2I cap plus 3J cap. And finally, at T is equal to 5, this is 13I cap plus 14J cap. Now it is asking you to calculate average velocity. Initially, this is 0. Then you also have witnessed 2 seconds, and then finally you have 5 seconds. But when we are talking about average, we are just concerned with initial and final. Whatever comes through the way or whatever distance is distance is covered, that we are not concerned of. So what we'll do, velocity average will become net displacement. This is the formula for it. Whatever is the total displacement divided by the total time. So how will we write the net displacement? This is 13I cap minus 2I cap, right? And same way, 14 J cap minus 3 J cap divided by 5 minus 0. So this becomes 11 I cap plus 11 J cap by 5. So 11 by 5 I cap plus J cap. Which option was it? D option. So D option is right. Note it down quickly, those who haven't written. Yes, Farhat and Ellen, correct answer. See, tan theta, you have to find out where angle of projection, horizontal range and maximum height are equal. So it means, what is the formula for range? R is equal to u square 2 sine theta cos theta divided by g, and h is equal to u square sine square theta by 2g. Both are equal. See, u square 2 sine theta cos theta by g is equal to u square sine square theta by 2g. U square, one sine will get cancelled. So you will be having 2 cos theta. One sine with the square will be equal to sine theta by 2. So 4 is equal to tan theta. Theta is equal to tan inverse 4. So B option. So only Saifullah has answered correctly. Others, there is some error in your answer. See, for maximum range, just now I had told you the formula for maximum range. It's a very easy question. U square by G. That's it. Put it. 20 into 20 divided by 10. What is the answer? 40 meters. So straight away, D option. Yes, Saifullah has answered correctly. Initial velocity U is 3I cap plus 4J cap. Acceleration 0.4I cap plus 0.3J cap. Time is 10 seconds. V is asked which equation you are going to use. V is equal to U plus 80. Put it to find out V. So V will be 3I cap plus 4J cap plus 0.4I cap plus 0.3J cap multiplied by 10. So that becomes 3I cap plus 4J cap plus, again, this will also be 4. This will become 4I cap plus 3J cap. So that becomes 7I cap plus 7J cap. Now, when you write its magnitude, that becomes under root 7 square plus 7 square. Or directly you can write 2 into 7 squares root 2. So 7 will be out, root 2 inside, this much of U. Any doubts you can ask class. All those who have written it, just text me done in the chat column. All right, class. So those who have completed, you can leave. We'll continue.